Hi guys, welcome back to my channel Code Ground. So today we are going to solve the daily coding challenge of October 19th, that is lexicographically smallest string after applying operations. Okay, so let's see what the question is. You are given a string of S of even length consisting of digits from 0 to 9. Okay, we are given a string which are consisting digits from 0 to 9 and two integers A and B. Okay, and also we are given two integers. You can apply either of the following two operations any number of times in any order on S. Okay, so we are given two operations and we can apply those operations on the string any number of times and in any order. Okay, so the first operation is add A to all odd indices of S. Okay, so to in the string to all the odd indices. What are the odd indices? 1, 3, 0 index string. So 1, 3, 5. All these indices will be odd indices. So we are going to add the integer a to all the odd indices. Digits post 9 are cycled back to 0. Okay, so if the digit is 9 and we are adding 1, let's say, it will not be 10, it will be 0. So for example, okay, let's take an example. 3, 4, 5, 6. 3, 4, 5, 6 and a equals to 5. So what are the odd indices? The odd indices are uh, 1 and 3. So the even indices 3 will be as it is. In the odd indices, in the odd index 1, 4 will become 4 plus 5, 9. 5 will remain as it is, and 6 will become 6 plus 5 is 11, but it will become 1. Okay, so yeah, in this way, the first operation is to be applied, and what's the second operation? Uh, Rotate S to the right by B positions. Okay, so we are going to rotate the string in a clockwise direction. Let's suppose the string is 3, 4, 5, 6 again, and B equals to 2, let's suppose. So what will the string be? So 3 will go 2 positions ahead, 4 will go 2 positions ahead. The 6 will come here, it will go 2 positions ahead, and the 5 will come here, it will go 2 positions ahead. So the string will be 5, 6, 3, and 4. Yeah. So in this way, these two operations are to be applied, and return the lexicographically smallest string you can obtain by applying the above operations any number of times on S. Okay. So we have to return the lexicographically smallest string after applying these operations any number of times. So what kind of approach we should use for this problem? So the approach that can be used for this problem is BFS, breadth first search. So what we are going to do is we are going to generate all the possible strings, and then we are going to store them in a queue, and we are going to remove the strings one by one, and we are going to keep a string variable smallest so that we can keep track of the smallest string until now. And then if the removed string from the queue is smallest than that smallest string, is smaller than the smallest string, then we are going to replace the smallest by this string. So this is what we are going to do, and for this we need to write code. So yeah, let's get started. We need a queue of string queue equals to new linked list. Okay, then so in order to optimize this, we don't have to see the we don't have to process the string which has been already processed. So we are going to keep track of all the process strings. So the best way to do this is using a hash set of string, because in hash set the search time complexity is constant. It will be O of 1 if you search for a string. If you search for anything in hash set, yeah. Let's name it as seen. equals to new hash set. Okay, now now string smallest equals to s. So this string will be the smallest string as of now. And next, q dot add s and seen.add s. Okay, great. Now, now we are going to start processing while queue is not empty. First, if not if, first we have to poll, right? So string car equals to q dot pull. Okay, so we have got the current string, and the first operation we are going to do is checking if the current string is, then current equals to, not current, smallest equals to current. Okay, so what we are doing here is, if current dot compare to smallest, what does this compare to do? So let's suppose we are comparing two strings, uh, a dot compare to b. What does this do? So always remember, if a is greater than b, means a is lexicographically larger than b, then it will return a value which is greater than 0. Else if a is smaller than b, it will return less than 0. If equal, it will return 0. So, yeah. So here what's happening is, if the current string is smaller than the smallest string, then it will return, obviously it will return a value less than 0. We are checking if it is returning a value less than 0. If it is returning a value less than 0, we are replacing the smallest string with the current string. Okay? Yeah. So this is what is happening. Now we have to perform the operation 1. What is operation 1? The operation 1 is, for all the odd indices, you have to add the integer a. So first, for this we need to convert it into a character array. So character array r equals to s dot, not s, char dot to character array. Okay. Then for all the odd indices they start from 1 for int I equals to 1 and I less than uh, array dot length and I plus equals to 2. Yeah, because after 1 we have to directly go to 3, so I plus equals to 2. And what we have to do, so first we have to find the value of what character we are going to get. So if, like, character of the current character is array of I, and we are going to minus 0. Okay, uh, we can do it either ways. Wait, so the character is 3, so we are to add it. 3 minus 0 is 3. Yeah, so we can do it this way. Yeah, 0 and plus a. This will get converted into an integer. So plus a and percentile 10. Because after 9, if we are going to add 2, then 9 plus 2 will be 11. But we need only 1. So 11 percentile 10, which will return 1. After 9, if we are going to add 5, 9 plus 5 is 14, but we need 4. So percentile 10 will be good. And then array of I equals to uh, character of val plus 0 again. Yeah, okay. So that will be converted into character again. And yeah, so now if scene dot contains new string of array, then it should not contain, so we need to apply the not here. Contains new string of array, then we can scene dot instead of creating the strings again and again, st string to add equals to new string of array. We can just put it here. Then scene dot add to add, and q also, q dot add to add. Yeah, so the operation one is done. A small point here. Scene actually returns a Boolean value when you are adding. So, like, if value already is, if the value is in set, then it will return false. If not in set and got added, it will return true. So, what we can do is we can remove this additional check. So we can just remove this, and we can just cut it, and we can paste it here, and this will work the same as the previous code. Yeah, so this is a small point in interview point of view. They'll ask you what does every question on I mean they'll ask you a question like what does every function on a collection return. So you should be thorough with those kind of things also. On a hash set, add function will return true if the element got added. When will the element get added? If it is not in the set. And it will return true. It will return false if the element did not get added. When does the element won't get added? It will not get added if the element is already in the set. Yeah, this is a small point to remember. And yeah, now we are going to perform the operation 2. Great. Now what's the operation 2? We need to rotate s. So okay. So string rotated equals to how to rotate a string. If you see, there's a small trick. If you want to rotate a string in clockwise direction by by some b positions, so get the last b positions and put it in the first. That's all. The string will get rotated. And if you want to rotate a string by b positions in anti-clockwise direction, then what you have to do? Then get the first b characters and put it in the last. Yeah. So now what we are going to do? String rotated equals to cur dot substring. We are going to do substring from where cur dot length minus b. The last b characters will start from cur dot length minus b to cur dot length plus and cur dot substring of from 0 to cur dot length minus b. Okay, so we successfully got the rotated string, and in the same way, if scene dot add rotated, then q dot add rotated, else, no, there is no else. Yeah, by this we have completed coding the BFS part. Now we have to return the smallest because the smallest will get updated in every iteration over here. So this is how we should code this. I think this should work. So let's see. Yeah. So this has worked for the sample test cases. And let's submit this. Great. So all these test cases have passed. So hope I have explained the solution well. I have written the comments here to understand like what's going on and some additional knowledge. You can take this because very few people know that this returns a boolean. And yeah, so this is how we should solve this problem. Hope you guys liked my video. Hope you guys drew some insights from this. So yeah, so thank you for listening. Please do like, share, and subscribe to my channel. And yeah, that's all. Uh, Thank you. Bye.